Okay, so we're looking at number 7-118 on your test review. The first thing it says, describe what happened when you tried to solve the system. So, of those of you who tried to solve the system, what happened when you tried to solve it? No solution, maybe? Something weird happened? Okay, when you're looking at these problems here, this system of equations, how did you try to solve it? Substitution? Yeah, I think substitution is probably the easiest. So let me go ahead and use substitution here. So I would take the 3x plus 2 and sub it into the second equation. So I would end up with 6x minus 2 times 3x plus 2 equals 8. Go ahead and simplify that out. 6x, distribute, minus 6x, minus 4 equals 8. Okay, these will cancel. Add to 0. You get negative 4 equals 8, which is not true. So it is a no solution. If you would have ended up with like negative 4 equals negative 4, then it would have been infinite solutions. B, it says graph the system of equations. How does the graph explain what happened to the equations? When you graph a no solution, what does that look like? Parallel lines. So these were just two parallel lines. In fact, I'm not sure. Let's see. I could probably do a quick sketch here of these. So 3x plus 2 would look something like that maybe. And then 6x minus 2y. Is that above or below 3x plus 2?
That'll be above. My bad.
Yeah, what I'm looking at here is I know the y-intercept here would be negative 4, right? If I covered up the 6x, I'd have negative 2y equals 8. So my y-intercept is negative 4. And we already know it's parallel, so it's going to have the same slope. So it'd be something like that. So parallel lines.
So if we use like a graphing calculator.
Oh yeah, you can use a graphing calculator on the test. It's fine. Notice here on this test, this question didn't ever really ask you to solve the system. And it said you tried to solve it. You didn't quite finish it. But that's kind of where it might end. So it's not like you have to solve the whole system. Okay, 119, same idea. Describe what happened when we tried to solve the system. So what did we get here when we tried to solve the system? If you didn't try to solve it yet, make a guesstimate what's going to happen. It might either be no solution. I mean, I'm guessing that it's probably a weird answer. It's not an actual system of equation answer. So it's probably either no solution again or infinite solutions. If I were to make a bet on this, I would just, I haven't done it yet. Infinite solutions make sense because we already did a no solution. But let's just try, see what happens. I would again use the substitution method here. And let's see what happens when I do that. So I would get 18x minus 3. Now I substitute in for y, 6x minus 3, and that equals 9. I can already see that when I distribute this, I'm going to get a negative 18x here, which will add to 0 or cancel out my x there, plus 9 equals 9. And I get infinite. Infinite solutions. If it's infinite solutions, what do they look like? It's the exact same line. So if I graph the bottom one here, just that's easier with the y equals, 6x minus 3 is going to be a pretty steep graph at negative 3, and then that means that this would also be the exact same graph and fall right on top of that line. So same line. Okay, on the test, I'm not going to ask you 4 system of equation problems like this. I might give you a couple. So let's look at B and C. So if I look at B here, what is the best way to solve that system of equations? Elimination. I would go with that. So if I do elimination, what's my first step in eliminating?
You multiply the bottom equation by -2.
Perfect. So like Jenny said, eliminate the x's first, and then Dominic said that go ahead and multiply the bottom equation by -2. So we'd end up with 4x plus 5y equals 11. And then negative 4x, when I multiply these out right here, minus 12y equals negative 32. Make sure I multiply the -2 by everything. Now when I eliminate, add down, I get negative 7y equals negative 21. That's nice. Y equals 3. And then I could sub that back in for any of those above. I'll try just the top equation there. So I'll sub it back into, oops, I just started the top equation. That's what I want to do. 4x plus 5 times 3 equals 11. 4x plus 15 equals 11. 4x equals negative 4. X equals negative 1. And there's my answer. Questions there? Okay, we'll look at C just because it's a different style of equation. As far as I probably would not eliminate there, I would use substitution. And we just did a couple substitution problems, so this shouldn't be too difficult. We're going to substitute the 1/4 y minus 1 here into the x. So I'll do that all in one step here. I'd have 4 times 1/4 y minus 1 minus 3y equals negative 10. It's kind of nice because when I distribute now, 4 times 1/4 is 1, so that would just be y. 4 times negative 1 is negative 4, minus 3y equals negative 10.
So negative 2y minus
Negative 2y, and I'll do this all in one step. Plus 4 plus 4. Negative 2y equals negative 6. Y equals negative 3.
It would be a positive.
Or a positive 3. Positive 3. All right, and I can sub that back in to the x equals. So x equals 1/4 times 3 minus 1. So I will get a fraction here. X equals 3/4 minus 1. So x equals negative 1/4. So final answer would be negative 1/4. And if I put it in system of equation, look, solution, look, comma 3. Questions?
Okay, how did you get the negative 1/4 from that?
So when I multiplied 3 times 1/4, I got 3/4. And 3/4 minus 1, negative 1, plus a positive 3/4, like subtraction there. So I'd have negative 1/4. Okay, 7-121. Juan is driving at 55 miles per hour when the speed limit's only 40 miles per hour in a work zone. Oh, Juan. A highway patrolman is 2 miles behind Juan and chasing him at a speed of 70 miles per hour. How long will it take the highway patrolman to catch up to the speeding car if they both maintain these speeds? Answer in hours and minutes. Okay, so let's call Juan. So J is going to equal 1. So how can I write an equation for Juan? Yes.
55x.
So I'm cool with 55x. So 55 miles per hour times x, and x is going to equal number of hours, right? So x equals number of hours. Okay? And then we'll go highway patrolman. So we'll say patrolman What's going to be his equation?
70x minus 2.
For 70x minus 2. Because they're starting in miles behind, right? So this is the distance. 55 times x is the distance that Juan has gone. And then 70x is the distance the patrolman's gone, but he started 2 miles behind. So that looks good to go. Okay, we want to see when he will reach them, catch up to them. So we want to see when their distances will be the same. So we can just set those equal. 55x equals 70x minus 2. Subtract the 70x from both sides. So we end up with 15x, negative 15x, equals negative 2. We're going to get a kind of a gross fraction here. So when we do negative 2 divided by negative 15, what do we get? 2/15. How about that in decimals? Okay, so we end up with 0.13, and the 3 is repeating. Okay, so that is in hours, because x was number in hours.
So 13.
So how would I change that to minutes?
Multiply by 60.
Yeah, so times 60. Times 60, that's a bad multiplication symbol. Times 60, 8 minutes. And the question was when he's going to catch up, and we're good, 8 minutes. Questions there? So the question was, what if we wanted to turn it into minutes instead of hours initially? We would just have to change these equations into miles per minute instead of miles per hour. So you would just do 55, that's miles an hour, divided by 60, and now it's miles per minute. So you're going to get some fractions when you do that in your initial equations. And then it would still be minus 2, correct?
Yeah.
Because you still started out 2 miles behind. If you solve those, set those equal and solve, now your x will be directly 8, but you have to deal with the fractions initially. So added to the test, we're going to add a couple absolute value equations. I probably will only add one equation, and it could be either one of these types, so that's why I wanted to go over both. So absolute value equations here. I'm going to solve both of these on this one slide, hopefully. So for B, when we solve absolute value equations, we want to isolate the absolute value first. So on B here, if I subtract the 3 from both sides, I would end up with absolute value of 2x plus 5 equals 14. Okay, and we want that absolute value to be all by itself on one side. And it is. Okay, now we want to get rid of the absolute value bars. So the way we do that is to make 2 equations. One equation is just to drop the bars. Because that 2x plus 5, if this equaled 14, we'd have absolute value of 14 and it would balance. Okay, the other equation, you'd have 2x plus 5 equals what? Negative 14. And again, it's the same reasoning. If this inside here, if I was able to cover that up and it equaled negative 14, absolute value of negative 14 is positive 14. So both of these would work. Okay, one mistake a lot of newer absolute value students make is that they always assume that, oh, x is going to be plus or minus a number. Not always true. Okay, it's true if your absolute value is if the x is the only thing in absolute value. Otherwise, it could be 2 completely different numbers, and that's what we're going to get here. So we subtract the 5, and you could solve each of these individually. You could solve both of them at the same time. I just do about the same time because you are going to take the same steps. 2x equals 9 for that one. 2x equals negative 19 here. Divide by 2. X equals, and you could leave it in fractions is fine. X equals 9/2. X equals negative 19/2. And again, I'd be okay if you left it just like that. All right, on C, it's the same idea. Just we're going to need to do a couple transformations. Subtract this 6 from both sides first. So we'd have negative absolute value of x plus 2 equals negative 3. And now we need to divide by that negative, or divide by a negative 1. So it ends up being absolute value x plus 2 equals positive 3. We can make two equations from this. We get x plus 2 equals 3. X plus 2 equals negative 3. And we can solve these all at once. Subtract 2. You get x equals 1. X equals negative 5. 2 answers and done. So questions about absolute value equations. I'll have probably one of those on the test. All right, last thing, and we've kind of talked about it a little bit, but I want to make sure that we're okay with this, especially the vertex and probably sketching a graph. But I definitely want you to be able to find a vertex of an absolute value equation, okay? And the x and y intercepts would be good. So on 3 here, if you can do this problem, you'll be okay in the test. This one says find the x and y intercepts of y equals the absolute value of x minus 3 minus 5. So x and y intercepts. Let's do that first. If I want to find the x-intercept, how do I do that with an equation? Anyone remember? Okay, when I want to find the x-intercept, what value is going to equal 0? The y value is going to equal 0. So the x-intercept is when y equals 0. So I'm going to set y equal to 0 and solve. How many x-intercepts is this going to have?
2.
2. Okay. What kind of shape is this going to make? Like a V shape. Like a V shape. Okay. So, and I should get 2 answers for this because we just did these types of problems. But to solve this, I would have to add the 5 to both sides. So I get 5 equals absolute value of x minus 3. I make 2 equations. I'll make them up here though. So I get 5 equals x minus 3 and negative 5 equals, out of room, x minus 3. Add a 3 to both sides. X equals 8. So that's one x-intercept. The other one would be negative 2. So negative 2 equals x. So we have 2 x-intercepts. So don't forget that. That means it says x equals 8 and x equals negative 2, but those are our x-intercepts. Okay, now y-intercept. How do I find the y-intercept? The same idea.
X is 0. You make X 0.
I make x 0. This is actually a lot easier because I get y equals absolute value of 0 minus 3 minus 5. That's just a simplify, right? So that would be 3 minus 5, which is y equals negative 2. Right? So 0 minus 3 is a negative 3. The absolute value of negative 3 is positive 3. Minus 5 is negative 2. So that's your y-intercept. All right, now we want the vertex. The vertex is the easiest one if you can remember how to do it. Does anybody remember how to do the vertex? Very similar to point slope form. Eric?
You make the x about like whatever is subtracting by the x, you make that positive or negative in this, like,
Do the opposite.
yeah, opposite, and then you just keep your y value the same.
That's your vertex. This is a vertex form right here. It's nice. And I'll give it to you like that tomorrow on the test. But you just take that, the opposite of that is 3, and then the y is negative 5, and there's your vertex. Okay? So now, I want you to sketch the graph of this equation. You don't need a calculator to do this. You have all the information to plot some points. You already know it's V-shape. So if I yeah, I'll just go, and again, it's just a sketch. It doesn't have to be perfect. As long as you label these points. So we're going to sketch this out. My vertex, make that kind of in a purple color. So vertex is 3, -5. So 1, 2, 3, 1, 2, 3, 4, 5. And label it. All right. My y-intercept is -2. So that's 0, -2. My x-intercepts are at -2. -2, 0. And at 8, 3. And if it goes off the graph like mine did, that's fine. That'd be 8, 0. All right, now you know how it's V shape, and this is the vertex at the bottom here. That's our vertex. So all I have to do is just go start the vertex. That's not pretty. Something like that. And there's your graph. There's your sketch. Questions, Eric?
So if you like change the -5 to +5, would that just make it like the opposite of it, or how would that work?
So you mean if this -5 or +5?
Yeah, that would. Yeah.
So your vertex would be up here, but that would have changed your y-intercepts and everything.
Okay.
You might not even have an x-intercept then. It might be like a V shape up this way. Or it could end up upside down and go this way.
Okay, but what would it be called if it like came that square?
It would still be, if it was an upside down V, it's still absolute value.
Okay.
All right?